Hey, welcome back. We're going to start talking about scatter plots, lines of fit, and prediction equations. So one thing that you may be wondering is why do we even learn how to do this? Well, there's a lot of real world events that model linear um, equations. And so it's really good if you have data sets, if you can determine a best fit line in a prediction equation, then you can make predictions about what will happen in the future if everything stays constant. So we're going to learn how to make a scatter plot, find that best fit line, and make a prediction equation. Couple of terms. A scatter plot is just it's a graph of a set of ordered pairs, and the ordered pairs come from two sets of data. This is starting out well. Can I just tell you? Two sets of data, all right, and they're graphed on a coordinate plane. So you've measured two things, and you want to see how they're related. The independent variable is on the horizontal or x-axis. The dependent variable is on the y-axis. And there are lots of ways to find a line of fit. We're going to use the eyeball method. Next year in either pre-calc or college algebra, you'll actually do a linear regression using your TI Nspire, but we're just going to eyeball it. Then we're going to select 2 points from our data, ones that represent the line well. We're going to find the slope, and then we're going to write an equation. So the next three, then we're going to determine how they're correlated, and we can tell that by looking at the movement of the points. All right, so positive correlation is generally when the points are generally moving uphill. They don't form a perfect straight line, but as you go across the horizontal axis, your y values tend to go up as your x values tend to go up. Independent variable increases, so does the dependent variable. It would look something like this. Like this. Oh, I can't make dots very well on my Lenovo here, but you can get the idea of what's going on. Just in general, as you go from left to right, the points are moving uphill. With a negative correlation, you're going to get a downhill pattern. Think about negative slope. As the independent variable increases, the dependent variable is decreasing. So what happens is we get something like this. It's going to make a downward sweeping motion. Okay, again, doesn't make a complete straight line, and you might even have a random point or two, but in general, as you increase your x's, as your independent variable increases, your dependent variable decreases. And then negative correlation is just, no relative correlation is no pattern at all. Generally, you get like a rectangle for that. So the next three slides is all going to be one problem. You'll have three basic parts. I'll do each part on a separate slide just so that we have more space and as visually we can see things better. It's going to be hard for me to put dots on this graph, so I'm going to use X's, but we're going to make a scatter plot. Okay, and this table shows the mean selling price of new privately owned single-family homes for selected years since 2008. So time is generally your independent variable or your x's. These are your x's. Your price is going to be your dependent variable. These are your y's. And notice what I did up here at the very top here. So 2008, that's like year 0. And then 2009 would be year 1. And 2011 would be year 3, 2004. It's just an easier way to put them on a graph instead of having to put 08, 09, 11, 12, 14, 16. All right, so let's go ahead and graph these and then draw a line and then decide if it's a positive or a negative or no correlation at all. So at year 0, 2008, I'm at roughly 155, right? So I'm going to go right here. And then at 2009, that's year 1, I'm at 166.4, okay? And at year 3, I'm at 181, almost 182. And at year 4, I'm at 207. And at year 6, I'm at 228, roughly 229. And 2016, or year 8, that's what I'm going to predict. That's what the question mark is for. All right. So now I'm going to just kind of sketch a best fit line. You guys have an advantage of using a ruler and just eyeballing one that just kind of closely approximates all of these points. And so this is what I get. All right. Now, as you notice, it's not a straight line. However, we would say that it is positive correlation. It is generally moving uphill. Now what we want to do is we want to select 2 of those points and calculate the slope and then write an equation. There is no magic right way or wrong way. I'm going to choose, oh, you know what? I'm going to choose this point here because that's like a y-intercept, and then this point here. So this is the point 0, 154.5, and this is the point 4, 207. So let's calculate the slope. Well, I know that I'm going to have a difference of 4 here. That's my x, change in x. And then 207 minus 154.5, that gives me 52.5. Now, if you pick 2 different points, your slope would be just a little bit different, okay? And when I divide that by 4, that gives me roughly 13.1. So now I'm going to write an equation, and I'm going to use my y-intercept. Notice that this is your y-intercept. So I'm going to go straight into y-intercept mode, and I get y equals 13 and an eighth, 0.125x plus 154.5. And that's my prediction equation. And now finally, part C, I'm going to use my prediction equation, y equals 13.125 x plus 154.5, and I'm going to plug in an 8. So that's like f of 8 equals 13.125 times 8 plus 154.5. And when I do that, I get a prediction of 259.5. That's $259,500. That's going to be my mean selling price in 2016. So you can see how this is very valuable to, in this case, realtors. You can have situations with manufacturers, with bankers, with scientists. So this is a really cool thing to be able to understand, and then when you actually get to do linear regression with a calculator, it's even better. So these are the problems that we're going to be doing in class tomorrow. Thank you for listening, and I will see you tomorrow.